Game changers. Welcome back to At the Desk with Dr. KwA, the podcast where transformation begins with conversation. Thank you for pulling up a seat. I had the privilege of interviewing Dr. Prince Koree Osei, president of the African Institute of Mathematical Sciences in Ghana, and also the director of Quantum Leap Africa in Kigali, Rwanda. The conversation certainly was rich, insightful, and definitely gave me a great vibe in terms of Africa's positioning for the up and coming quantum revolution. The conversation, of course, recording live, we experienced so many challenges. However, we were able to salvage enough of the conversation to let you get a sense of where Africa is going with its representation and presence in this quantum revolution that's pending. Dr. Osei, insightful, very knowledgeable, and of course, a great guest for the desk. So I hope you enjoy the conversation. And while you're here, by all means, make sure that you subscribe again, like, and by all means, make sure you share. Enjoy the conversation with Dr. Prince Osei. Game changers. We are actually at a desk for a change. Welcome to At the Desk with Dr. KwA, the podcast where transformation begins with conversation. This is a space where leaders, educators, scholars, and innovators come together to explore the ideas shaping our world and the possibilities that lie ahead. Today's conversation takes us into the future of science, technology, and global innovation. Across the world, nations are investing heavily in emerging fields such as artificial intelligence, advanced computing, and of course, quantum science, technology that will define the next era of discovery and economic development. Today with me, I have Dr. Prince Koree. I keep saying Koree, it's Koree. See, this is what happens when you don't pay attention to names. Prince Koree Osei, who is currently the director of Quantum Leap Africa in Kigali, Rwanda, and of course, the president of African Institute of Mathematical Sciences in Ghana. The question that comes to mind each time we have these conversations is, what role will Africa play in shaping the future of this quantum science and the future of this new innovation that's at play? And so, as a theorist, academic leader, someone who's building capacity with engaging scholars to participate in the sciences, I am excited to have you live because, we are in Ghana. Ghana was the first nation on the continent to gain its independence. And of course, your interview is the first truly at the desk with Dr. KwA. So Dr. Osei, welcome to At the Desk with Dr. KwA. Happy to have you.
Thank you very much. I'm very, very pleased to be here.
Okay. So my knowledge of quantum anything, let me see. Ant-Man and Wasp, Marvel Comics movie, they use quantum science to shrink people and all of this stuff, right? There used to be a show years ago called Quantum Leap, where there was a scientist who can travel through time and all of this crazy stuff. You are a trained theoretical physicist working in areas such as quantum algebra, quantum geometry, quantum information. For many people, the word quantum is both fascinating and mysterious. So to help us, how would you explain quantum science in a way that allows the average Ghanaian, the average American, the average global entity or person to really kind of appreciate its significance?
Okay, thank you very much. To answer your question, maybe I start by disappointing you in saying that quantum science is actually mysterious to a scientist.
Okay.
Even to the quantum physicists. So it's just a fundamental theory of physics that describes the microscopic world, the atom and all particles below the atom. So in physics, there's the microscopic world, there's a medium scale physics, and then there's the large scale physics. The large scale physics, for example, is described by Einstein's theory of general relativity. So that describes the physics of the cosmos and the universe.
Right.
But quantum physics is a theory for very elementary particles, and that's help us to understand light and matter and so on. And it's a theory that has really made us understand our physical world, and it has led to all kinds of inventions in the past century.
Really?
For example, all the cell phones and the computers that we have now came out of quantum science.
Really?
So, so this is what we call the first quantum revolution, where quantum science made us understand our physical world, and also led us to the discovery of semiconductors and all the equipments that we have currently.
Wow. So, as someone, you know, when I sit with people and they're in these fascinating fields, my question is, what originally drew you to this? Like, you know, in my collegiate years, when I was in School of Engineering, you know, differentiated equations and all of those things. It was like, Lord, I don't want to sit through that class. I don't want to sit through DQ, as we used to call it. What drew you to this field?
Okay, so I have always enjoyed doing mathematics.
Okay.
And when I finished university, my first degree, whilst I was doing my first degree, I took some courses in physics and also applied mathematics, theoretical physics. But I wanted to tackle some of the most challenging problems in the world.
Okay.
And so with some colleagues of mine, we searched online at the time, very, very limited.
Wow.
And we discussed what is the top unsolved problems in the world in mathematics and physics. And so we chanced on some of the very difficult number theory problems that is very hard, that no one has been able to solve for centuries. But then there was one problem that really caught my attention, which is the problem of quantum gravity. So, and this is the problem of trying to unify. So quantum theory, I said, is the theory for the microscopic world.
Right.
Now, I also mentioned the theory for the macroscopic world, large-scale physics, the theory of galaxies and the universe, and that predicts the origin of the universe and the fate of the universe and so on.
Right.
Now, these two theories contradict each other. So, one of the biggest challenges in physics is to understand how we can unify these two, how we can bring a theory of quantum mechanics into large-scale physics, or we can bring the understanding, the understanding of the universe and the theory of gravity, and combine it with and the contradiction is very, very severe and significant.
Really?
That for example, at a small scale, there's a concept of we live in space and evolve in time. But for large-scale physics, there's nothing like time, and that objects are just described by some very complicated manifolds that have some geometries that so it's I don't want to go into details of that, but so I really found that fascinating.
Okay.
And very hard. So I decided that okay, this is what to go for.
So the harder the concept or the course or the application, that's where you wanted to go.
Yes. So the problem, solving the problem of how to unify the theory of quantum and the theory of gravity is what I decided to go for. And that's what I did. I did my PhD.
Oh, nice. Nice.
See, that's how come I got into quantum stuff.
Wow. Wow. So individuals like you fascinate me because, all of us, our minds are racing and running in various ways. Those of you who can focus like this, I find so fascinating. Now, I know you lead the African Institute of Mathematical Sciences in Ghana, which plays a major role in advanced STEM education on the continent. What is the mission of AIMS, and why is it such a critical institution for Africa?
I think I will, let me give you 3 points.
Okay.
Okay. So the origin of AIMS was founded on, let's say, 3 things. So the first one is that the ability to do major scientific discovery or breakthrough scientific work is not limited to a particular race, a particular gender, or a particular culture.
Okay.
And that ability and potential is universal. So that's the first thing. The second thing is that young Africans are capable and are able to do breakthrough research, scientific research, when they are given the opportunity. Okay, so that is the second one. And the third one is that Africa can be transformed if we build a critical mass of young Africans who are able to use science and technology to transform society. So we believe that we can transform Africa through innovation in mathematical sciences. And that is upon these 3 pillars, I think, is the reason why AIMS exists.
So I love the fact that you're talking about young African scholars having the capabilities, just the need for opportunity. The other thing that also needs to be taken into account is the fact that we also have the youngest population globally. So whereas everybody else seems to be getting older, right? We have a young, up and coming population that definitely can make this work. So with that, Quantum Leap Africa and the future of research. You also serve as the director of Quantum Leap Africa, an initiative designed to advance research in quantum technologies on the continent. Tell us about this initiative and the vision behind it.
Okay. Let me pick back on your comments about the young population of Africa. So I love this article in the New York Times, which came out a couple of years ago, I think November 2023. And the title was Old World, Young Africa. And I encourage you to have a look at it.
I will certainly do that.
Yes. It clearly shows how there's a lot of data that if you map the median age across the world, how Africa is in the 10s when the rest of the world are in their 30s and 40s.
Right.
And it's very important for us at AIMS because it's important for us to provide opportunity for some of these young people in Africa to participate in breakthrough discovery and technologies such as quantum science. Well, Quantum Leap Africa is an initiative of AIMS, which I led, and the whole idea, the world has gone through different revolutions. So we've had the Industrial Revolution, we've had the Digital Revolution. Now we are in the 4th Industrial Revolution, and all these, Africa is trying to play a catch-up. And there's a quantum revolution on the horizon, and we think that we cannot afford to miss the quantum revolution in Africa because that promises to be the most disruptive. If you think AI and the 4th Industrial Revolution is very disruptive, then you haven't seen anything yet.
Really, I applaud the work that you're doing to help bring young female scholars into the field of the sciences. You know, we are still working on those aspects as well on the other side of the Atlantic, where I taught and try to get my scholars to get into the sciences and all of those things. Um, the thing that's also fascinating to me, I'm looking at my notes because I have to make sure I get these questions in, right? Global collaboration. You serve on international advisory bodies, including Open Quantum Institute Advisory Committee and the World Economic Forum's Global Future Council on the Quantum Economy. From your vantage point, how is the global conversation about quantum technology evolving?
Okay, I think it's going well.
Okay.
We have started early, learning from mistakes of AI.
Okay.
The global conversation is going very well. We started early. So, for example, at the World Economic Forum Global Council, we developed a blueprint for the future of quantum economy that a lot of industries and governments can look at and draw as a guide to develop their own quantum strategies and plans. We are creating a lot of awareness among global leaders and industry. There's a lot of you mentioned the Open Quantum Institutes. There we are making a deliberate effort to ensure access of quantum technologies to underserved geographies. We are also there's a quantum diplomacy and games and all kinds of things that is going on there, involving a lot of diplomats and then we are also in the education, which is very critical. There's a lot of initiatives and collaborations going on across the globe in ensuring capacity building of young people in the field. So I think we've started at the right time. We started early enough. There are some concerns, export controls, which are concerns. These are natural because these quantum technologies are very powerful. And these are some of the things that we are trying to figure out a way around, but there has been very strong collaborations from researchers and scientists across the world in developing these technologies.
So as you're talking, I'm going, what would it take for Africa to become a major or significant contributor in this global knowledge economy? What would it take for us to get to be like if not at the head of the seat, right next to the man at the head of the seat? What would it take for us to be in that position?
I think the answer is simple, but the willingness of African leaders to make the investments is where the challenge is.
Okay.
We have the talents, we have the young people who are willing to participate. We need more leaders we need more pioneers, we need more leaders, we need more advocacy. But at the end of the day, we need to contribute and invest in developing this technology for ourselves.
Absolutely.
Because there are, before I ran the Quantum Hackathon last year, I was trying to get 50 of my students to run simulations on a quantum computer. And one organization that has quantum computer, I mean, these computers now are not at the functioning level. So these are still being built way below far below what we expected to.
Is it just on this side or is it global?
We are globally.
Okay, just want to make sure. Yeah.
And I got a quote, $1,000 per hour per student. So for my 50 students, I need to pay $50,000 for 1 hour to run their experiment.
Wow.
And so now we have remote access to some companies, quantum computers, and so on. But there's a risk. I mean, we've already started seeing it. You can be shut out. You can, and the more you use their computers, the more you improve the computers.
Right.
And you get to a point where
they want to take over.
When the computers are perfected, then you don't have access anymore. So I think African leaders and institutions need to make a deliberate effort to invest in the development of the technologies on the continent to serve their needs as well.
So as you're saying that as well, here's where I'm going. I know that you've taught for more than 20 years at university level courses. And you've held leadership roles as well in higher education. From your experience, what must universities do differently to prepare scholars for the future of science and this technology that we're talking about? What must universities do differently?
So I have been talking about some ideas about reinventing the university of the 21st century, especially for Africa.
Nice.
And I normally use the Ames model, for example, as one typical example.
Okay.
Where we have limitations. For example, if you take quantum science and technology, there are very few researchers and faculty on the continent now.
Right.
And what the Ames model does is bring people, Africans, young Africans from all over Africa under one roof, and then bring the experts from different parts of the world to come and teach them. So bringing the best lecturers from all over the world and some of the most talented students on the continent together in one place, we have seen is so powerful and generates a lot of possibilities.
Nice.
And some of our students from these have gone on to do amazing.
So when you say have gone on, because I have a question about that as well. Have gone on the continent or have gone on outside the continent?
Both.
Okay.
So, but we have 70% of our students on the continent.
Okay.
And involved in all kinds of initiatives, amazing initiatives, and making impact across the continent and also elsewhere in the world.
We're getting a little closer to the tail end of our conversation, and I really want to just say this. I want to get your advice for young scientists, right? Whether they're on the continent or anywhere else. Imagine a young scholar watching this conversation after we're done, perhaps in Ghana, Rwanda, or somewhere else in the world, who's curious about science, but unsure if they belong in that space. What message would you want them to hear about their potential role in shaping of the future of discovery?
I think I'll just say one thing. They should just do it.
Just do it.
So you never learn until you do it. And that is something that from my experience over the past is a lesson that I have carried along. And once you take the initiative, the ideas will come. Once you have the good ideas, and the resources will come. So and no matter where you are, whether you are in a refugee camp somewhere, when you have good results, your results will bring you out.
Okay.
So it is important for you to believe that you are capable. Like I said in the beginning, the capacity to do this is universal, and it is not limited to a particular gender or culture. And there is a lot that science needs to is going to benefit from. There are some cultures that have not even played a role in
The process.
the process and the scientific discoveries we have currently. And we need new ideas. So we need new ideas from different thinkers, from different backgrounds to be able to address. And sometimes I face some of the hardest problems that we have if we are able to find which communities and which groups across the world who have not even studied science before. These are some of the communities that our
Bringing them into the equation.
from. Yes.
Fresh ideas, fresh new lens. So I like that. I like that. So leadership often requires both courage and clarity, right? From your perspective, what is the most important leadership quality needed to navigate today's rapidly changing world?
Oh, that's a
This is your part in words of wisdom for us.
that's a tough one. I always ask myself whether leaders are born or leaders are made.
Mm.
And I think that it is I have asked some people these questions, some amazing leaders, and also whether genius is born or genius is made. I've asked some amazing geniuses, and my conclusion is that it's about a decision.
Okay.
It is not about nature or nurture, but it's about the decisions you make. So leadership for me, it's about making the right decisions and taking responsibility for it. And I think that is what I will leave with, decisions. So whatever decisions you make, ensure that you get all the information necessary to make that decision, get the best counsel possible to make that decision. And when you make a mistake, don't worry. It's okay. You pick up and then you move on.
And I think that's a great advice because one of my all-time favorite quotes comes from Robert F. Kennedy. Right? Some people see things as they are and ask why. I dream of things that never are that aren't and ask why not. Right? So why not try that? Why not do that? And you use a line that I've tormented my scholars and my staff over the years. Try it out. Just do it. Try it out, right? Because you never know until you try it out. And so my son is probably going to enjoy that line a lot more because he hates it when I force him to have to, try it. Oh, but I try it. Or I don't like this food. Try it, right? So all of these things, again, one has to be intentional in the process. And I so much want to say thank you for sharing your insights,
Pleasure.
your knowledge, your scholarship, your vision for the future of science and innovation across Africa. Game changers, conversations like this remind us that the future of discovery will be shaped not only by technology, but by the people and institutions committed to expanding knowledge and opportunity. And to our listeners and viewers, game changers, as I'll call you, thank you for joining us. Here at the desk with Dr. KwA, we believe that transformation begins with conversation. So today, the discussion was powerful. And what can happen when thoughtful ideas meet purposeful leadership? Dr. Osei, I appreciate you again. Until our next meeting, I am Dr. Kwame Redu Asante, a.k.a. Dr. KwA. Thank you for being part of the conversation. Thank you.
Thank you.
For taking the seat. Appreciate it. We finally got it, man.